Hello and welcome to third lecture in 11th chapter in our comprehensive course on artificial intelligence, machine learning and data science. Now in this third lecture, we want to do this, applying custom functions using apply and map. This itself tells custom functions. So that means what is the use case for apply and map? When you will remember that here I should try apply and map. When pandas built-in functions are not enough. So pandas and numpy together form a formidable pair, and they have a large number of built-in functions, so that most of the simple manipulations of data are done by those built-in functions. But sometimes you need complex manipulations, so at that time built-in functions are not available for doing that type of manipulation. So at that time you use apply and map. When to use apply and when to use map, I mean they are totally different things, but what does apply do? Then apply is used to apply a function along one particular axis, either along a row or along a column, and you have to decide. You can tell Panda that this is to be applied along this by specifying axis is equal to 0 for rows or axis is equal to 1 for columns, that we know. Okay, this method is versatile and can be used to apply any function. It can be used to apply a built-in function also, and it can be used to apply your user-defined function also, and you can make it applicable to single column or multiple columns and single row and multiple rows. While map is slightly different thing. Okay, first let us do about apply and then we'll come back to map. As usual, we create our own data frame. So this is the dictionary. A, B and C, they will be the column headers. A will be filled with these numbers, B will be filled with these numbers, and C will be filled with these numbers. So let us create our data frame. Now it is clearly seen that A is 1, 2, 3, 4, 5, B is 10 to 0 with not including 0 of course, with a step size of -2. So that is why 10, then 8, then 6 and so on. And C is 10 to 15 with no step size is defined, then 1. Here also no step size is defined. Then the default step size is 1. Therefore it is 1, 2, 3, 4, 5, and similarly this is 10, 11, 12, 13, 14, 15. Fine. So we have created our data frame. Now we define one function. Okay. Like this, for example, we are asked that define one function to calculate the range for each column. So range means maximum value minus minimum value. Okay. So 5 minus 1. Here that will be the range. Yeah, sorry for the interruption, but actually range of first column would be 5 minus 1. So 4. Range of this column would be 10 minus 2. Max minus minimum. So that is 8. And range of this C column would be 14 minus 10. So that would be 4. Now, if you remember, we have one that df.describe, but it gives maximum and minimum values, but it does not give range. This is minimum value and this is maximum value, but it does not give range. So if you want to find range, what should you do? And remember, these are only 3 columns, so you can even from the output of describe you can manually calculate. But think about a data set which has say 120 columns. Now what will you do for that? Will you manually calculate? No, you will define your own function, and it is a very simple function that calculate range, in which we will pass one column as a numpy array and return x dot max. Max is a built-in function minus x dot minimum. So x is the column name which you have passed, and then apply that column. So first let me define only the function. So this function will return the range. Now if you define that function, then how to apply it to every column of this data set? So it is very simple, df.apply, and with that you have to write the function's name, calculate range, and you have to specify axis is equal to 0. So axis is equal to 0 means you are applying the function calculate range column wise. So what will be passed first? A column, and its range will be returned. Then what will be passed next? B column, and its range will be returned. And what will be passed next? Then C will be passed and its range will be returned. So if you print out that, I think function I need to define first, yes, and then this. Then you can see A has range 4, B has range 8, and C has range 4. Very nice and quick way of defining the range. Okay, that range is a measure of dispersion of data, how spread your data is. Of course, we have better measures like variance and standard deviation, but range is a basic measure. Okay, then apply the function to each row of data frame. Now that is interesting, that the same function which you have defined here can be applied to each row of data frame also. So at that time also we will supply it with same x. X is our data frame which you want to whose every row you want to calculate range, but you are passing with axis. You are calling the same function calculate range, but you are passing axis is equal to 1. So that means row wise. Okay, so remember here the axis is different. I think earlier perhaps I spoke wrong thing. Maybe I think I spoke axis is equal to 0 for rows, but actually this will, as such it is row wise calculation. We are finding range for column, but the calculation is row wise, that you can see 5 minus 1. So that means you are moving across rows. So that logic wise, okay, row wise calculation, and it will give result for a column. Similarly, this is column wise calculation, and it will give result for a row. So what is the range for the first row? Then 10 minus 1, so 9, 11 minus 2, so that is also 9, 12 minus 3, that is also 9, and 13 minus 4, 9. And so every row has 9 as the range. And you can see it is 9. Fourth row has 14 minus 5. Sorry, 14 minus 2 it is, right? Lowest value is here. So that is why it is 12. Fine. Now here for the, you can see that means that original what I spoke was correct only. That when you write axis is equal to 0, for finding range it will traverse row wise, and therefore it will give the range of columns. It will go maximum and minimum value this way. Similarly, when you specify axis is equal to 1, then it will traverse the data set column wise like this, and therefore you will get the range for each row. I think that this is clear. One important thing is the axis is equal to 0 is the default value. So even if I don't write that and just write df.apply and my function, whatever function I have defined, okay, so then you will get the same result. Okay, so but sometimes instead of writing that way, for better readability of code for other programmer, it is better to be explicit, but it is your choice. Okay, now this is just the explanation which I gave. Now it is not necessary to use defined function only, that is custom function only, user defined only. You can use a built-in function like np.square root, okay, and then you can calculate the square root of each and every observation. For example, here only, though this is a different picture, here perfect squares are given 9, 25, 9, 25, 9, 25. So if you use apply, df.apply, and in bracket write np.square root, then you will get the square root of each element, okay, square root of each element, so 3 and 5. But I can do that same thing for our data set, df.apply, and in bracket, instead of my custom defined any function, I am writing np.square root. I can just write np dot and push tab and s, then square root somewhere will be there, yes, here. So np dot square root, and it is a function, so I have to write like this, and then I want to print its output. So what is the issue? df.apply np.square root is okay, just this should be given that way. Yes. Now you can see my variable, I mean my numbers were not perfect square, but at least this one was there, so its perfect square is its square root is also 1, that you can see here 1. Okay, rest of the numbers were not perfect square, so their square root is coming out to be the in floating point number, but that is fine. The point is I can use apply with in bracket parenthesis any user defined function, and there also I can specify axis is equal to 0 or axis is equal to 1, so that axis is equal to 0 will traverse row wise, and therefore it will apply the changes to the columns, and axis is equal to 1 will traverse column wise, and therefore it will apply the functional changes to the rows. Okay, so that is how it is. And now map, I think map we had kept somewhere pending, no? So yes, map is primarily used for transforming the value of series. So when I say that series, so it is clear that map will work on NumPy PANDAS series, and each column of a data frame is nothing but a PANDAS series. So this is a column individually, if I take, then it is a PANDAS series, this is PANDAS series, and so on, from one value to another using a dictionary or a function. This is important, use from one value to another using dictionary or a function, and therefore it is ideal for element wise transformation. What is the meaning of this whole sentence, using dictionary or function, ideal for element wise transformation? That becomes clear as we take some examples. So map, for example, again let us create our data set first. So that is the same data set. Now suppose I am asked that these values in column 1 are 1, 2, 3, 4 numbers. Instead of that you write same values but as a string. So instead of the number 1 ONE, here TWO, like that. So what you can do is df a, because you don't want the change to apply over other columns. You can do that also, but then it will become very long dictionary here. So that is why for the demonstration, suppose I want to apply change only to this column, and so df a dot map. So map, now map how? That is specified by a dictionary. The key of the dictionary should be the original values in the column. So 1, 2, 3, 4 and 5. These are the original values in the column, and the values in the dictionary, they should be the replacement value of the column. So instead of number one, I want this to appear. So how to remember this syntax? It is very simple. Series name, your PANDAS series, because I said that each column is nothing but a PANDAS series dot map, and then your mapping function or mapping dictionary. So data mapping. How do you want to map each element to some other value? Okay. Here you can also specify one parameter na.action. Okay, because sometimes it is possible that there is a null none here. So at that time it might be confused if you do not specify that, and it will throw error. So in that case you can write na.action is equal to ignore, or some parameters are there, and you can easily put those parameters. Or instead of na.action you can write na.fill mean of that column. So it will fill the non value with the mean of that column, like that. Okay, but this is the syntax: series, then dot map, and your data mapping. So after map you have to explicitly specify your data mapping, because you are now not doing column wise operations. Previous square root or etc., they were applying over whole column, range, etc., which we did. Now we are applying element wise operation. Each element is to be changed in a different manner. So that means 1 should be changed to this, then 2 should be changed to a different value, 3 should be changed to a different value. Element wise operation. So you have to provide your mapping for every element, detailed manner, and original value of element becomes the key of the dictionary, and the new value of the element, that becomes the value of that dictionary. Okay. Now let us do this first, and then let us print the mapped value. Then you can see that the first column, which was 1, 2, 3, 4, these are the index. Now that first column has become string 1, 2, 3, 4, 5. This is the index. Okay. So you have converted successfully. Now where this can be used? This can be used, for example, sometimes your data has a value M and F, for male and female. Now you got a new boss and he says that no, I don't want this M and F. It is not clear enough. I want full words. That is male MALE and female FEMALE. So then you will have to, if you take the data in Excel sheet and manually change each male to MALE and all that, that is also a method. But now think about if there are 10,000 rows, then what you will do? Then instead import that Excel sheet to PANDAS and apply such mapping function. So that will convert male to M to male and female F to female. Okay. So now let us discuss some such examples. So data frame column name, that is the series, PANDAS series dot map and mapping function. That is the standard syntax for the map, and it will do the operation on each element. So it performs element wise manipulation of data. Okay. Now let us take one. It can also do manipulation by using a function. See, here we did manipulation, that is after map we specified a dictionary, but there are many ways of using map. You can use map with a by specifying a dictionary, or you can use map by specifying a function here, or you can use map by, there is a third way also, that is by specifying a series. Okay. So yes, so let us do how to do mapping using a function. A very common daily life example, that often we require to convert temperature from Celsius to Fahrenheit. Then Celsius to Fahrenheit is converted in this manner, that if you are supplied, you are given that value in Celsius is this much, then the value in Fahrenheit is value in Celsius multiplied by 9 by 5 plus 32. This is a ready-made formula. So this function takes a Celsius temperature as the argument, converts it into Fahrenheit temperature using this formula, and returns that value. Okay. So now let us create one data frame. Initially it has only temperature in Celsius. Now suppose I am asked that I want another column besides this, which will have same temperature calculated in Fahrenheit also. So at that time I can do this. This column is to be manipulated. So whichever column is to be manipulated, that is the first thing which comes here. After which there is a dot and map will come, and after map, whatever you are using for mapping, that will come. So here you were using a dictionary for mapping. So after map, that dictionary came. But here in this Celsius Fahrenheit case, I am using a function for my mapping. So that function will come. Here the name of the function is Celsius to Fahrenheit, right? So a function is coming, and then using that function, every temperature which is in this Celsius, that will be mapped to Fahrenheit. Again here also nothing is specified, so this column will be traversed row wise. Okay. So let us do mapping, and once the mapping is done, what result you will get means what will be the return value? The return value will be Celsius multiplied by 9 by 5 plus 32. That is, it will be temperature in Fahrenheit. Then let us save that in a new column of the data frame. So now my data frame will have two columns. Original column is already there, temperature underscore Celsius, and I am adding a new column, temperature underscore Fahrenheit, by mapping my temperature underscore Celsius column using the conversion function. Are you getting? Okay. So let us do that. Then you can understand easily now, and it is a nice table. So once you have done that, then you will not have to calculate again and again. you can convert multiple temperature and thousands of temperature in one go. And next time whenever you need Celsius to Fahrenheit, you just refer your table. Okay, this is how your out column will change. So I'm deleting this now. There is no need of this because or okay, let me delete that. No need. Then dictionary based mapping that we have already done once for converting this 1, 2, 3, 4 to ONE1 TWO2. Again, another example for dictionary based mapping. So for that we create one data set first and print the data frame. Again, the method is standard dictionary based. So this will become one column. This will become another column. These are 5 rows in this column and these are 5 rows in the genders column. It is original genders. Okay. So these are there. Now I am coming to that problem only. That suppose boss has come and he says that no, I don't want M and F. I want explicitly written MALE and FEMALE. So at that time you can first create gender mapping by using one dictionary. Okay, you can create a function also that gender mapping. Then take the value of the gender, and if original gender is M, then convert return MALE, else return FEMALE. But that would be too tedious and kind of overkill for this simple mapping because it is just converting one letter to one word and another letter to another word. So a dictionary is ideal case for that kind of case. Okay, so gender mapping I'm doing this way, and then my standard method is there. I will take the column whom I want to map. So df original genders. That means I'm taking this column. Then I will put the dot. Then I will put the map, and inside I will either write my mapping dictionary or my mapping function. Here I have mapping dictionary. So dictionary, fine. And then I will store this modified gender as a new column. So I am adding one new column in my data set. Okay. So if I print that, of course, df will be needed to be printed to display the result. Then you can see that M is mapped to male and so on in one go. Again, that is very handy if you think about 1 million rows. Then what will you do? This is the quickest way of doing it. Okay. And then you can even drop this row. Okay. So then in next step you can say that df dot drop and write this original gender in quotes. So this column will be dropped and your boss will also be happy. Okay. This I can delete. Then series based mapping. So one was function based mapping. Syntax remains the same, that PANDAS series or the column name, that is dot map, and inside whatever you are using for mapping. If you are using dictionary for mapping, then specify that dictionary. If you are using a function for mapping, then specify that function after map in parentheses. And if you are using a series based mapping, then first create that series and specify that series. So let us take one data frame create a data frame for our example. So suppose these are the names of 5 students and these are their grades. Name is the column and grade is another column, and these are 5 rows. Okay, so you can see a data frame like this is created. Now suppose a new principal comes and he says that no, I find this type of grades A, C, B, D very ambiguous. So better to convert them explicitly. Say A is equal to excellent and B is equal to very good or good, and C is equal to average and D is equal to poor and F is equal to fail. So it is fine. First create that kind of mapping by pd.series. So this is called series based mapping. A series is also nothing but as such a dictionary only. So then A key original values you provide as a key. So A here, then B here, then C here, then D here, like that. And instead of that, whatever value you want to replace, that you provide as a value in your PANDAS series. So it is also just like dictionary based mapping in a way. Okay. And then use your standard syntax that whatever column you want to map to new value, its name dot map, and in bracket whatever method you want to use for mapping, either dictionary based mapping or function based mapping or series based mapping. I have created a series, so I'm putting that series here. Okay, and let us print the data set after mapping. Now this is a nice way of displaying the result. Okay, now it might be possible that while suppose this is a data of entire school and there are 3,000 or 5,000 students in the school, and it might be possible that a few entries have none in them. So that means grade is not there. So you have to gracefully handle that, and for that we can, rather than series based mapping, we can write a function and functional based mapping. So again it is the same data almost, but there is one entry which is Raj, whose grade is not known, and similarly there is another one entry Smita, whose grade is also not known. Okay, so this is that data frame. Now I define a function that if the value is equal to A, then in that case replace it by return excellent, C then return average, B then return good, D then return poor, and F then return fail, and else. So else means now pd dot is na value. That means that this function is na returns true or false depending upon if the value here is a none or not. So we are writing that if is NA is true, that means if the value which is being passed is true, then write not available. But if something else is there, you have only this many grades A, B, C, D, F, but suppose by mistake somebody has written a grade G or say H, so that is also possible. Then anything else, then just write other. Okay, so that is my function. First define the function and then follow your standard method. So the method I am taking in the next cell, but first let us define the function. Now standard method is which column I want to modify, grade column. So df in parenthesis square bracket grade. Okay, then dot map, and inside I can modify either by using a dictionary, then the name of that dictionary, or a pandas series, then the name of that pandas series, or a custom function. So here I am using my custom function, so custom mapping function, and then print that there. So you will see that you are getting this kind of situation. So original data frame was ACD none df none. So ACD none df none, but now it is replaced by words, and wherever none was there, it has put not available. Okay, so something more legible for layman who is not working in data science field. Okay, now let us say few more examples which are real life examples that you will often have to do this type of things as a data scientist. Now for example, here this is a simple data frame in which there are two columns only, name and age. Okay, and each column has 5 entries, so 5 persons are there and their ages are there. So you can see this kind of situation. Now you are asked that bin them. Bin them means say convert them into child, adult, and senior maybe. So child is some definition is given to you that anybody less than 18 years is child. So these two should be put in child, means John and Sarah, they should be put in child. Anybody above 60 or 65, right? That should be put in senior. So this person, that is Amisha, that will be put is senior, and rest of the people are adults. So less than 18 child. So that you have just defined a function that df categorize age, and in that you will specify age as a variable. That is the values in this column one by one you will specify. Now if that value is less than 18, then return child. So for these two, it will be written child will be written. For this, adult will be written. For these also, adult will be written. And if it is less than 65, then adult, and greater than 65, else means if both these conditions are not satisfied, that will both will not be satisfied for this person. So then in that case, return senior. Now once the function is defined, the method again remains standard only. Start with the column which you want to element wise modify, put dot and then map, and inside that you either write the dictionary which you want to use for mapping, or you want to write the pandas series which you want to use for mapping, or you want to use the function, the user defined function. So here I have defined this function, so I want to use that. So then this, and let us even keep not only age, store this new value of age in age group, and you can see that with each observation of age, his group is already there, child, adult, etc. You can do the same thing by group by, but that will reduce the number of rows, right? So because that will put all child in one group and all adult in one group. So as a result, only 3 groups will be visible to you: child, which will have 2 members; adult, which will have 2 members; and senior, which will have 1 member. But if the requirement is such that you want to just add one column describing the age group of the person apart from the age in years, then you can do that. Okay. Then converting textual data into numerical values. Earlier we did numerical to textual. That was somewhere 1, 2, 3 was converted to ONE1 and so on. Similarly, now this is textual data to numerical value. Now where such thing can be helpful, for example, there are many binary classification problem that for example, simple, you have customers data and the gender is written as male female. So you can just write that male is equal to 1 and female is equal to 0, because all machine learning algorithms require the data to be fed in number format. They cannot understand the strings. Similarly, in the customer's data, there is another column whether the customer is active or inactive. So again, you can write active is equal to 1 and inactive is equal to 0. So that is a classic case where converting text to numerical value is required. Okay. So let us create one such data frame. This is the name of customer and this is the status of the customer. Okay. And now we want that status should be mapped. Now whenever it is a binary thing only 2 possible cases are there, then using a function would be overkill. Just a dictionary would be enough. Whatever original value are there, they become the key. So active and inactive, they will become the key. And whatever you want to put instead of them, they will become the value. So write active and value 1 and inactive value 0. That is a dictionary. So this is now your mapping dictionary. Then use your standard method, that df status dot map status mapping. Okay, status mapping. So in that case, you will see that that will give you df status binary, right? So df status map status mapping, that gives df status binary. Binary means that it will give same state, a new column, status binary in which active would be 1 and inactive would be 0. And I don't want to display say just that column, but I want to display entire data frame, and that would be better for comparison. So I have added a new column like that. Then I can drop this column. So in data science, this will be required in practically each and every problem, that you have to convert the string columns or object data type into numeric columns like this. Okay, and at that time there are certain techniques called encoding. Now binary encoding is very easy, and there is no need to use any encoding technique. And even if you use some encoding, built-in encoding technique, they internally use this kind of thing only, use map only. Okay. This is one another, calculating age from birth date. Now this is slightly difficult thing, but this is again often required, that you have your customer's birth date from which you want to find their age, so that you can target your customers based on their age for a marketing campaign. So this is my data, and I have the birth date of different people. Now I want to convert them into, or I may say, instead of convert, I want to add a new column in which birth date may remain, but on the right side of birth date an age column should also come. Okay, so you can first define a custom function. Now this is not a simple conversion, so that can be done by a dictionary like this kind of thing. So here a custom function will be required. So from datetime, import datetime library. This is a Python's library, just like NumPy, Panda is there. Whenever you want to do anything with age, years, date, then this library is very helpful. Calculate age function, and that age function takes the birth date as an argument. So these values will be one by one supplied as the argument to this function. What the function will do? First, it will calculate today. So that is very interesting. That will keep the function always relevant. So you are calculating age dynamically. That means whether you use the script today or tomorrow, first it will calculate the today only. What is this datetime dot now? If you print output, then yeah, importing is left. So first, like, I will have to execute this, and now you can see it will produce a timestamp like this, that today is 22nd of November 2024, and even hour, minute, second, up to microsecond. Okay, so datetime is very powerful function. So this function does what? It first starts with that date on which the function is called, and it subtracts the birth date, but birth date has to be subtracted in a special manner. You cannot directly subtract this. So from today's, you have to separate its three elements: year, month, and date. So this is the year separated from today, and from birth date also you have to separate the year. So only 1990. Then from today's month, you have to separate the month. So only the month will be separated of today, and day, and you have to use birth date's month and birth date's day, like that. Okay. So then that will give me the difference in age. This is more complicated than it appears, because what will happen, sometimes the difference of days, today day and the birthday day, is say 35 days. So that means it is actually more than 1 month. So in the day, month difference, 1 should be added, right? And in the day difference, only 5 should be kept. So such complications are there. Similarly, sometimes when you do today month minus birthday month, so at that time it will take maybe 15 months. So that is more than 1 year. So then this difference should be added by 1 year, and 15 months were there difference between the months. So that would be replaced by 3 months. 12 months have been shifted here, and 1 year has been added in the year difference, and 3 months is the month difference. So your homework or assignment is to find what is this operator. Okay, this less than like symbol. Okay. So this is that function. Now method remains the same. Whatever the column you want to map. So I want to map that column, df birthday, then follow it by dot map, and inside write either the mapping dictionary or mapping function or mapping PANDAS series. So I am writing mapping function because I have defined a function here. So if you write that and then I print my df, so then you can see that the age is calculated. This is of course rounded of age in years only, but it is more than enough for most of the cases. So a 46-year-old customer should not be targeted with some youngster item, or maybe you should not target that person with what is a typical youngster item, maybe a very gaudy type of t-shirt or something. And at the same time, a 22-year-old person should not be targeted with some item which is meant for senior citizens or something. So such classification is required. So a data which was like this, only birth date, was not much useful. But a data which is converted into this form, now suddenly it has become valuable data, because your marketing team will become very happy to see the data in this format and not in this format. Now you know that at most of the places they ask for birth date and they say that we'll send you some special discount coupon on your birthday. They do send that also, but the point was not just sending the discount coupon. The point is the meaning of the customers. Okay. Now here these are the exercises, and these are the ways to create the the required data. Again, I have given the required data creation code so that every learner will have the same code and the answers will match. Okay, and just create this data using the code and then uh, solve the exercise question. You will get the solution later on. About this first, it is a new way of producing the data. Normally, we produce the data by using a dictionary, but here we use a list inside which there are individual dictionaries. This is a very tedious way of producing a data frame, but it works. Otherwise, you can see it would be very short. Here, product ID, product ID, product ID is repeated so many times, product name. Instead of that, if you would have used the dictionary with column name equals to key, then 4 column names will be product ID, product name, and category. Only 3 column names. So only 3 will be the keys. And in the values, here, after product ID, you will provide just a list 1, 2, 3, 4. So that would up to 10. So then in product name, you will provide another list, laptop, desktop, chair, running shoes, like that. And in category, you will provide a list, electronics, furniture. So this data you try to produce by 2 methods and check if you get the same data frame or not. Okay. The second method which I am telling is the method which we have been using for last 4, 5, 6 chapters. Okay. So it should not be difficult. Okay. See you in next chapter. Thank you.